Picture this. Kazakhstan, 1957. An expedition digs up a dinosaur skull near the Aral Sea.
Okay.
Then, like almost 50 years later, that same skull. It completely throws a curveball into how we understand dinosaur evolution. Let's unpack this.
It's fascinating, isn't it, how just one sort of incomplete fossil can force such a big shift in thinking.
Totally.
So today we're diving into Aralosaurus tuberiferus. It's a hadrosaurid, a duck-billed dinosaur from the Late Cretaceous found in Kazakhstan.
Right. And we've got the whole story. The discovery, what scientists first thought it was, and then crucially the relook that flipped everything.
Yeah.
Our mission, really, is to figure out what this limited fossil evidence actually tells us about Aralosaurus itself, its world, and, why it matters for the bigger picture of duck-billed dinosaurs.
Okay.
So where does this whole puzzle start?
Well, it really kicks off with that first find back in 57.
Okay, right. So this partial skull plus a few other bits and pieces like an ulna bone, maybe a piece of femur.
Scattered postcranial bits, yeah.
They found these near Shakshak in central Kazakhstan. That was part of the USSR then, during a Soviet expedition.
And the rocks they were found in belonged to the Bostob Formation.
Got it. But it took a while to get a name.
It did. It wasn't until 1968 that the paleontologist Anatoly Rozdestvensky officially named it Aralosaurus tuberiferus.
And the name itself is pretty descriptive, isn't it?
Very much so. Aralosaurus means Aral Sea lizard, obviously, because of where it was found, northeast of the Aral Sea.
And tuberiferous.
That means bearing a tuber or a bump. It refers to this distinct, sharp rise on the nasal bone, just in front of the eye sockets, like a little bony outgrowth.
Interesting. So what exactly did they find initially?
Well, it was the back half of the skull, no lower jaw, unfortunately.
Ah, shame.
Plus some isolated teeth and those fragmented limb bones you mentioned, ulna, radius, femur, tibia, fibula, some foot bones. Only a humerus, the upper arm bone, and one metatarsal, a foot bone, were actually complete.
Not a whole lot to go on, really.
Not a huge amount. Based on that skull fragment, Rozdestvensky estimated the full skull was maybe 65 centimeters long.
Which suggests the whole animal was about.
Around 6.5 meters long, he figured. Roughly 21 feet.
Okay.
And another key thing, the skull bones weren't fused together tightly.
Ah, suggesting it was young, not fully mature.
Exactly. Probably an immature individual.
So with this skull piece, the bump, the size estimate, how did Rozdestvensky first classify it?
He placed it within the hadrosaurine. Now, that's one of the main groups of duck-billed dinosaurs.
Right, the ones that either didn't have crests or had solid bony ones, not the big hollow structures.
Precisely. His reconstruction included a kind of nasal arch, and he thought it looked similar to Cretasaurus.
Cretasaurus. But wait, isn't there a story with that comparison?
There is. It's a classic example of how science updates itself. The specific Cretasaurus fossils he was comparing it to, we now classify those as Gryposaurus.
Huh. So the comparison point itself changed identities later on, like a paleontological mix-up.
Sort of, yeah. It muddied the waters a bit initially.
So this idea of Aralosaurus being a flat-headed or solid-crested hadrosaurine, that was the picture for decades.
Pretty much, until that 2004 study. That's when Godefroy and his colleagues took another look.
And this is where the story takes that big turn.
A really significant turn. They re-examined the skull but faced a problem.
What was that?
Some of the key bone fragments Rozdestvensky used for his reconstruction parts he identified as the nasal arch and the premaxilla, the very front snout bone.
Yeah.
They seem to have gone missing over the years. Lost.
Oh, no. You can't check the original interpretation if the pieces aren't there.
Exactly.
Yeah.
It made verifying that initial reconstruction impossible.
Wow. But they must have found something else.
They did. They focused on that tuber, the bump that gave the species its name. It wasn't a solid boss of bone. It was actually a broken piece of a hollow structure.
Hollow. Okay, hold on. Hollow structures on the head. That sounds like the other major group of hadrosaurs.
Precisely. The Lambeosaurine. Godefroy's team found basically no convincing features linking Aralosaurus to the hadrosaurine anymore.
So all the signs pointed elsewhere.
Yes. Features in the maxilla, the upper jawbone, the parietal bone at the back of the skull, the squamosal on the side, and especially that nasal bone, they all indicated it belonged with the Lambeosaurines.
The ones famous for those elaborate hollow head crests connected to the airways.
That's the group. They found a definite piece of the back of the nasal bone rising up in front of the eyes, clearly forming part of a hollow, crest-like structure.
So the tuber was just the broken base of a crest.
It seems so. They confirmed the nasal bone itself was hollowed out, with a channel connecting to the respiratory tract. That's textbook Lambeosaurine anatomy.
Incredible. So that initial picture, like Cretasaurus or Gryposaurus, was just wrong.
Completely off base, based on this reinterpretation. It was likely a crested dinosaur, although probably a more primitive type.
So a total rethink. A solid bump turns into a piece of a hollow crest, shifting it to a whole different branch of the family tree.
Exactly. And because that crust fragment was broken, we still don't know the full shape or size of the original structure, but the evidence for it being a Lambeosaurine was strong.
And I guess that reclassification didn't stop there. Science keeps refining things.
It does. More recent studies have dug deeper into where it fits within the Lambeosaurine.
And what's the current thinking?
It's now generally seen as the most basal member, sort of the earliest offshoot of the Lambeosaurine lineage.
The root of that crested branch, maybe?
Kind of. A 2013 study, a cladistic analysis by Prito Marquez and colleagues, actually put Aralosaurus into its own little group, a tribe called Aralosaurine.
Aralosaurine.
Okay.
Hey, any other members?
Yes, alongside its closest known relative, a dinosaur called Canardia.
Canardia. Where was that found?
France. From the very end of the Cretaceous, the late Maastrichtian.
Whoa, hang on. France. Aralosaurus is from Kazakhstan, much earlier in the late Cretaceous.
Yeah.
It's a huge geographical and time gap.
It is. It's about a 20 million year difference.
So what does this relationship imply? Kazakhstan to France, 20 million years apart.
Well, it suggests Aralosaurus represents a really early phase in how those Lambeosaurine crests evolved.
How so?
Compared to the later, more famous Lambeosaurines like Parasaurolophus or Corthrothosaurus, the crest structure in Aralosaurus, or what we have of it, seems to be positioned more towards the front of the skull, ahead of the eyes. And the top of its skull didn't have the same kind of reinforced areas you see in later forms, which presumably helped anchor those bigger, fancier crests.
So a more primitive crest setup.
Right.
But that France connection is still puzzling.
It raises fascinating questions about paleobiogeography, how dinosaurs spread across the world.
Right.
Canardia lived on what was called the Ibero-Armorican Island, basically, the westernmost island in the archipelago that was Europe during the late Cretaceous.
An island dinosaur.
Yeah. And finding Canardia there, which is still a pretty primitive Lambeosaurine for its time, suggests maybe that island acted as a sort of refuge.
A refuge for this Aralosaurine lineage.
That's one idea. That this lineage, originating way back with things like Aralosaurus in Asia, managed to survive out on this European island long after maybe becoming rare elsewhere.
Huh. A dinosaur lost world, almost. But how did they get from Asia to an island in Western Europe?
The hypothesis involves migration, probably in the later part of the early Maastrichtian. They might have used temporary land bridges that popped up connecting Asia and the eastern parts of the European archipelago.
Island hopping.
Possibly. Moving from Asia across to the eastern European islands and eventually making their way west to the Ibero-Armorican island. It would have been a long journey over immense timescale.
That's incredible to think about, these vast migrations across a changing planet. Okay, let's zoom back in on Aralosaurus' home turf. What was Kazakhstan like back then?
We look to the Bostob Formation rocks for clues. The sediments are mostly clays and sandstones.
Which tells us?
Suggests environments like floodplains, estuaries, river systems near the coast.
Makes sense. And the climate?
Likely subtropical, maybe even bordering on tropical. This area was essentially the west coast of the Asian continent at the time.
Coastline. So there was ocean nearby.
Yes, it bordered the ancient Turgai Sea. This was a shallow sea that actually connected the Big Tethys Ocean in the south to the Arctic Ocean up north.
Wow, a major seaway.
And it seems there was coastal upwelling, deep, nutrient-rich water coming to the surface just offshore.
What effect would that have?
High biological productivity in the water, but maybe also strong onshore winds. Some evidence suggests these winds might have caused a bit of drying, some aridification on the coastal plain.
Interesting. Did that affect the plants?
It seems so. The flora changed a bit. Flowering plants, angiosperms were definitely dominant, like 75% of the plant life.
Okay.
But the types changed. Broad-leaved flowering plants became rarer, while smaller, narrow-leaved ones, especially from the elm family, Ulmaceae, became more common.
So elms were around back then. What else was growing?
Still had conifers, and some less common things like ginkgos and cycads, a mixed landscape.
So Aralosaurus is munching on this vegetation. But it wasn't alone, was it? You mentioned other finds at Chukchak.
Oh, absolutely not alone. That site yielded a really diverse fauna.
Like what?
Okay, let's see. Various fish sharks, rays, bony fish, frogs, at least 6 kinds of turtles, some huge, with shells over 75 centimeters long.
Big turtles.
Yeah. Plus a type of lizard, crocodiles, pterosaurs. The flying reptile, Aralosaurus, was found there.
Aralosaurus.
Birds, early mammals, and then a whole bunch of other dinosaurs we only know from fragments.
What kinds?
Things identified as belonging to the Ankylosauridae, the armored dinosaurs. Sauropods' long necks. Tyrannosaurids, relatives of T-Rex. Ornithomimids, the ostrich mimics. The Resinosaurids, those weird long-clawed herbivores. Troodontids and dromaeosaurids, the small feathered predators related to birds.
Wow, that's a crowded ecosystem, a real Cretaceous menagerie.
Definitely a busy place, and other spots in the Bostock Formation, like Akurgan, have given us other dinosaurs too.
Such as?
More primitive hadrosaurids, like Arstanosaurus and Batasaurus, and another pterosaur called Simbruchia, though some think that might just be another specimen of Aralosaurus.
It really shows how much is still being figured out.
Constantly, every find adds a piece, or sometimes makes us rethink the whole picture.
So let's sort of wrap up our deep dive on Aralosaurus, the Aral sea lizard. It's pretty clear it's a key player, giving us this important look into the early days of the crested duckbills.
Absolutely, and it's such a great example of how science works, how reanalyzing old fossils with new eyes, new knowledge, can completely change our understanding.
Yeah, that shift from hadrosaurine to Lambeosaurine is dramatic,
It really is. And then there's that fascinating connection to Canardia in France.
suggesting those incredible dispersal routes across the continents over millions of years.
Exactly. It just shows how even quite limited fossils, half a skull, some bits and pieces, can challenge what we thought we knew and open up whole new questions.
Aralosaurus is definitely a testament to that. The story isn't always straightforward.
Not at all. It reminds us that the history of life is full of these unexpected twists.
For sure. And it leaves you wondering, we only have that partial skull. Imagine finding a complete Aralosaurus.
Oh, that would be incredible.
What could that tell us about the exact shape of that early crest? How did it use it? Was it for display, sound, something else? And just picturing it moving through that bustling Kazakh ecosystem.
It really fires up the imagination, and it makes you think what other secrets about dinosaur evolution, about these ancient migrations, are still waiting out there, locked in the rocks of Kazakhstan and places like it. What's the next discovery that might rewrite the story again?